we are going to continue our discussion about molarity and concentration. We already figured out this problem when we have moles and liters in the previous video. This time we're going to look at this one. We have grams and liters. Now I'm going to let you know right away that there are some things you might want to review that affects you for this stuff. The first thing are significant figures, right? And that's notebook page 25. That is going to affect you. Oh, that's fuzzy. There we go. The second thing that's going to affect you is converting grams into moles. We're going to use Mole Island for that. And somebody told me earlier today, that's in your notebook, page 107. The third thing that's going to give you trouble is chemical formulas. Right, you have two major types of chemical formulas. You have ionic or covalent, and it's a three-step process getting an ionic one done. But this is the first thing you need to do, is figure out if you have ionic or covalent. Right, you do that really simply. Ionic are metal made out of metal and non-metals, and a covalent are made out of all non-metals. The next thing, if it's ionic, where are my colors went? Is if it's ionic, you need to identify the symbols and the charges. And the last thing that you need to do is to crisscross. All of this is in your notebook, but we're going to come back to this as we move through this particular problem. So we are going to we're going to come back to this. I'll keep that nearby. Right? So we've done problem 1. We're going to start problem number 2. So here it is, a little bit larger. 1 gram of potassium fluoride is dissolved to make 0.10 liters of solution. Again, this is big M, and if this helps. Okay. So you are always going to be calculating molarity for me. We have moles and we have liters. This liter one is easy because it's already, it's already in liters. But the moles are not present. So right here, right, I have 1.0 grams. And then I have been given words. So we have to figure out potassium fluoride, if it's ionic or covalent. Potassium is found in group 1, so it's a metal, and fluoride is over here, it's a non-metal. Therefore, potassium fluoride is going to be ionic because it's made out of a metal and a non-metal. So we got to identify our symbols and charges and then crisscross. I'm going to do that over here. So potassium is in group 1, so it's a charge of +1, and fluorine is a halogen, and it is a charge of -1. So the crisscross here, it's a 1-to-1 ratio, so KF is the formula. Now, I have to get from grams into moles, so I'm going to come back to this one. I already did this. So I need to go from grams to moles. On Mole Island, it tells us that 1 mole is equal to molar mass. So we're going to have to calculate the molar mass. I have a K and an F on the periodic table. I have these numbers and 58. .089, and that's grams per 1 mole. Now I know I'm going through this pretty quickly, but these are all very old scales, so that is my conversion factor. So I have KF. I have grams here on top, so I'm going to put grams on bottom. KF, 1 mole, KF. Right, so my grams cancel and the KFs cancel, and 1 divided by 58.098. I can only report 2 significant figures. Right. Again, all of what I just did is old skills. So now we're going to just wrap this up. Here is my new formula. Now I have everything that I need. Mole divided by liters, 0.017 mole, KF, divided by 0.10 liters, and 0.07. Both of these have 2 significant figures, so I can report 2. We just figured out the molarity when we were given grams and liters.